So yeah, hi everyone. Great to have you all here to our Ask Me Anything session with the Foundation's core developer team. I'm really happy to have here today Ulf Vigger, Dimitar Ivanov, Fabian Kroll, and Mitin Akata. And yeah, I'll give the word to Dimitar to give us a short summary about what's going on with the Foundation's Q3 roadmap.
Hello. So let's start. First, we're going to discuss the state of affairs of Hyperchains. Then Ulf is going to tell us about how the progress of the RocksDB is going and some key points there. Then we're going to briefly go through Canary, Rosetta, and Launcher, and we'll have some time for questions. So let's start. Hyperchains. At this point, we have a delegated proof of stake contracts. It's a set of contracts, and we're expanding and improving those. For example, you cannot see it at the moment from the UI, but delegates have names, they have descriptions, avatars, and other information that can be used for branding. So we did a small refactoring there actually. So far, what we used to have was strictly proof of stake election, and because of Hyperchains, we want to be improving that in adding the proof for components. And so we still wanted to keep the proof of stake in case someone wants to build a proof of stake chain, private chain, for example. So we took the election part out as a separate contract. So now we have 4 contracts. We have 2 delegation of stake contracts and 2 different election contracts, and every one of the election contracts can work with their own consensus module essentially, and with the other delegate contracts. This allows us to have a lot of flexibility, and this is the progress of Hyperchains. We also have parent chain connectors. We have a parent chain connector eternity to eternity, and we are developing a parent chain connector eternity to Bitcoin, which is still work in progress. We'll discuss what is missing there. But obviously, there is still no fork resolution. There is no accumulation of difficulty on different forks. The UI at this point is really simple, and it allows to inspect your staking power. The staking and staking works, and we have a lot of stakers, but we're going to visualize this in a better way. So what are our plans now? As I said, we have a eternity to eternity connector, but it's not connected to the contract. So essentially, we have to use the parent chain key block hash and propagate that through the consensus to the contract, so the contract can use that as a source of entropy. This is work in progress, and maybe we're a few days away from seeding the entropy from the parent chain. After that, we'll start posting commitments, and we'll be consuming those commitments, but that's further down the line. As a parallel tasks, we are doing different smart contract improvements. So the Hyperchains Alpha smart contracts they were really like a demo. And for example, still a validator cannot withdraw their stake. So if you become a validator, you essentially burn your coins, and they're locked forever in the smart contract, which is not cool. And there's some flags that we're enforcing. For example, who can withdraw, when you can withdraw, and etc. So we're adding important and missing pieces in the smart contract. And once those are in place, the contract will be in a much safer place. Like it's going to be much safer to use for users and the chain. So it matures gradually. After we have commitments on the parent chain, we can start building up some chain difficulty, fork difficulty, and we'll have a decent fork resolution. We're constantly improving our test suite. As you remember, we had a bug in the smart contract that we were corrupting the probability space of user becoming a leader, a validator becoming a leader, and we developed extensive test suite for the contract functionality, and now we're more confident that there are no bugs in it. But as we're adding more and more functionalities there, we're adding appropriate tests. So our test suite is improving as we go. Another parallel task is that we're improving the UI. So what the current UI is doing is we are dry running a lot of stuff, and we are using a lot of the Erlang infrastructure. And since we want Hyperchains to be accessible for everyone, we started developing a new tool, a radically new tool that is only consuming the JavaScript SDK, the TypeScript SDK at this point. So, well, you're going to see it. Not today. Maybe on the next call, we're going to show off what we have there. Our deployment process for Hyperchains is really ad hoc. We're producing releases that have really strange version numbers and etc. So we're going to be improving that as we progress the development. And yeah, now I think it's Ulf's turn to tell you something about how the RocksDB progress goes.
Okay, so I will share my own slides here. And yeah, I will give you a little bit of background. So I don't know if you've noticed, but on occasion we've seen errors in the eternity nodes where it seems like an object is missing or something, and the software doesn't accept that, so it crashes. I don't know if you've perhaps experienced it yourself, but we've seen it occasionally in testing and elsewhere. This we have identified as an artifact of the combination we're running with the Erlang database Mnesia and RocksDB as a backend. And it's a little weird edge case that I will explain briefly. Another problem that I'm sure you've all experienced is that syncing the chain could be faster than it is. So we've wanted to address that as well. Now we're pretty close to releasing an update, and so I will a little background. So for those who haven't used the Erlang programming language, it comes with a basically a complete distributed soft real-time database, which is unique in many ways. And one thing that's a bit unique about it is that it really feels like an extension of the programming language. So it's very nice to use from a productivity standpoint. It was initially completely RAM-based in-memory database. And then persistence was added, and it was also naturally distributed for telecom systems, fully redundant, things like that. And it has some extremely good properties in that area. Now, it also has, I think, an undeservedly bad reputation in some cases, partly because it's so easy to use that people just jump into it and start using distributed database processing without understanding what an extremely complex area that is. And then it doesn't work perfectly, and they think Nisia is to blame for it. So anyway, it went fairly quickly from being a RAM-only database to a RAM and disk database. So they added something called disk copies. ETS is Erlang term storage. That's basically hash tables inside the Erlang VM. Extremely handy. Disk copies is just same but checkpointed to disk, but that means all your data resides in RAM. Now, for a blockchain node, that's kind of a losing proposition over time. Disk only was used for those who wanted to store data on disk, but kind of like with MS-DOS back in the old days, this was late 90s. It was limited to 2 gigabytes in size. Not very impressive today. So it's practically never used by anyone. Then there were some issues with distributed processing, which we don't need to get into because we're not using distributed Nisia. Now, as I said, the disk-only copied version is pretty much unusable. A more subtle problem is that when they made this move, they used the same API and the same semantics for the disk-based accesses as for the RAM-based accesses. Now, this is really not a good idea because you have completely different failure modes when you go to disk compared to when you write in memory inside your virtual machine. Back in 2016, I helped Klarna develop a backend plugin interface so that you could plug in other database key value stores for use in Nisia. And we've added a couple. LevelDB was the first one. LevelEd is, well, an Erlang-based key value store. RocksDB is a successor of LevelDB, which is maintained by Facebook. And there is also an experimental Postgres backend, but it's of little interest for us, I think. Now, Klarna uses this for a database that's over 600 gigabytes. I don't know how big it is now. A little bit big to have it all in RAM, even though they were using some ridiculous machines with, I think it was 4 terabytes of RAM. But this was really, they had really good experiences with the LevelDB backend. So when we started back in 2017, this seemed like actually a pretty good way to start. Now, the Eternity blockchain has one problem that the Klarna guys perhaps don't have, and that's when you have a stateful blockchain, you have tremendous write pressure for all the state updates. Now, write pressure means you can actually get, let's see, IO system saturation. And this is bad for any database, which basically means when you try to write out something to disk, it may actually stall completely. Now, there are ways to cope with this in RocksDB. The default was actually to simply drop the update. This does not make Nisia happy, and that was actually what was happening to us. RocksDB was saying, oops, the IO subsystem is saturated, so I can't write now. But Nisia had handed the access over to RocksDB after the point of no return, as far as Nisia was concerned. it viewed the data as committed, and it wasn't written. So this was the weird interaction that happened. Now you can also set it to wait. I believe that's what we do now, and that can actually give reasonably long stalls if you have a slow system that's really badly saturated. There are some rate limiters in RocksDB that we haven't played with so far. I think it's time to do that, where it looks at basically how much compaction it needs to do, log merging. And if that is piling up, then it starts slowing down writes so that you can avoid the stalls. This is for future work for us. Yeah, let's skip that. We also had a problem with file descriptors because, as a remnant from the LevelDB days, each table in the Mnesia database became its own RocksDB or LevelDB instance. And a backend instance can use up quite a few file descriptors because it uses lots of logs at different levels that it keeps merging. So we ended up with, that's why we have this requirement for lots and lots of file descriptors, which I believe probably increases the IO pressure problem, but I'm not sure about that. So, but with newer versions of RocksDB, they have something called column families, which is basically logical tables. And so we wanted to rewrite the database backend so that each Mnesia table was mapped to a column family. And that also has atomicity and consistency advantages. And should also, well, we've been testing this with default number of, well, on my machine, I have 1024 file descriptors as a limit, and that seems to be working very well with this. Now, RocksDB also has other things that are really good. It has transactions, it has atomic batch updates, snapshot views so that you can iterate over a consistent view of the database. Very nice things. So this opened up the possibility of simply also keep using Mnesia to set up all the tables. That also allows us to be compatible with, say, the RAM-only backends that we're using for testing, but provide an API against RocksDB that looks like the Mnesia API, but uses the RocksDB transactions and RocksDB accesses directly. You shouldn't use both at the same time on the same data sets, at least not for now, but if you want to go for more performance, you could use the MRDB API. And it's crafted so that this should be a fairly easy switch. So essentially you can start Mnesia and then you can read and insert data, and you can do, for those who have been using Mnesia, these things look almost exactly like Mnesia API calls, except they're using the new API. So I did some performance. This is just general transaction performance, where you can see this is writing, the blue is writing, the yellow is reading, and the gray is transaction batch. And you can see that RAM copies are blazing fast on both reading and writing, and also pretty fast on transactions. Disk copies are as fast as RAM copies on reads because it's all in memory. Disk-only copies suck overall. The old RocksDB copies that we were using are reasonably good, but the MRDB API looks to be significantly faster, almost like the RAM-only Mnesia tables, and actually faster on transactions. So we did, now that we've actually merged it to master, we haven't actually made a full release yet. We did a sync test where the light the blue here is the, sorry about the wrapping. I did this in PowerPoint, and now it's I'm using LibreOffice Impress, so the rendering wasn't quite up to par. These are 3 nodes. The purple is using the MRDB API. That's the newest one. The yellow is using, well, same as before, but also using some really dirty optimizations, scraping data from the Amnesia commit store and committing via batch updates. This should actually be safer, but also faster. And the blue one is the 6.5.2 release, the latest one. So you can see that the 6.5.2 release, this is timed up to a height of 230K blocks. The 6.5.2 release took almost 21 hours to sync up to that level. We don't know exactly why it took that long, but hey, could be networking, could be disks. These are equivalent machines anyway. The one with the dirty optimizations took 10.5 hours, and the one with the direct API, which doesn't really do anything ugly, it's actually a little bit cleaner in many ways. It took under 9 hours. So a very significant speed up in sync compared to the latest release. So, and on my machine I have a 1 gigabit fiber network, syncing took 12 hours up to the top last week. So it depends on what kind of hardware you have and everything. So, but anyway, it's certainly a massive improvement. So next step for me would be to improve the garbage collection. Now we're only garbage collecting the accounts state tree, partly because we don't want to, well, we wanted to rewrite the garbage collection implementation, and also with the file descriptor problem, because essentially we end up using multiple tables for garbage collection, and we didn't want to increase the file descriptor problem even more. So we were waiting for this rewrite to really get going on this. So once we implement this and garbage collect all the tables, now for example, the naming system, there is a lot of potential for garbage collection there because of all the old auctions, pre-claims and everything. We're thinking that we will attack the sync. We've been experimenting with what we call spine sync, where we sync only all the headers and the key blocks. That takes a few hours, but it's reasonably quick. And then we were thinking that we could pick a height not too far from the top, sync the entire blockchain state that's reachable at that height, and then go from there. This should be a dramatic improvement in sync speed. Now, so the way the garbage collection would work is for each state tree, like accounts, contracts, names, oracles, for example, you have a table which implements a Merkle Patricia tree. So what we will do is we will have a pair of tables where one is empty normally. One would contain the entire state tree up to a certain height. So say at height H0, we will then set the empty state table as the new one, and we will start traversing the state tree from that root hash, the root hash at that height. And then we can find from there all the states we can find. That's all the live state at that point. And we will just simply access that and store that in the new table. And for each successive block, when we process that block, we read all the state that that block needs. And we look first in the new table. If we don't find it there, we look in the old table. If it's not there, it isn't there. And if we find something in the old table, we simply copy it to the new table. And then we move on with all the blocks. And once we've processed, say, 1,000 blocks, if that's the garbage collection height, from H0, then we can delete the old table. So that will become the new table in the next iteration of garbage collection. So that's essentially how it could work. And this should give quite a bit of compaction in size. And this will also be quite useful for hyperchains. So that was pretty much what I had planned to say.
Okay, so I take over.
Mm-hmm.
I start sharing my window. Can you see my window?
Yeah.
Yeah. Okay.
Yes.
So, what we've said is a couple of different really big tasks that we have ahead of us, and Hyperchains is still our top priority. But still, when we have some spare cycles, we're working on different areas. And I'm going to briefly go through different areas that we plan on progressing further. So the canary has a few identified bugs, and we want to fix them. If we have the time, we'll implement. We have this pending tainted accounts issue that we want to implement, but depending on our availability, we might work on it or not. If the Hyperchains area becomes too tight, so we'll start having trouble working together and we'll be stepping on each other's toes. We'll move some resources to Canary. Another subject that is long overdue at this point is the Rosetta API implementation. The bad news is that developer that was working on it quit. Chandler is no longer amongst us. So Sean took over that, and he will be working on this depending on his availability. We really aim at finishing this quarter. The problem is that essentially it's a big API set, and it's really good fit for Ethereum and for Bitcoin, and it's really bad fit for Bitcoin NG consensus. And we're encountering all types of problems there, and we're fixing them on the go. So Sean will be working on that. Hopefully we'll have it really depends on his availability. I don't want to promise that we're going to deliver it soon. For those you don't know, Sean is traveling at the moment in a sailboat. He's sailing, so his availability may vary. We're also making progress with the GUI Launcher. A new version is going to be released in the following days, maybe. Basically, it will have some really neat functionalities for creating contracts and, using it as a studio. And you can play with it using some node fundamentals. But once this is done, we'll write on the forum. And yeah. So that's our roadmap. I think we're ready for some questions. Okay, the first question. How come Rosetta API is a bad fit for Bitcoin NG if it works with Bitcoin and Ethereum? We don't have enough time for that. So
well, I mean, you could say that Bitcoin NG sounds more similar to Bitcoin than it actually is, because it has Bitcoin in the name. But I mean, one problem is that in Bitcoin you have all the transactions in the next block. You have all the transactions in that block. That's not how Bitcoin NG works. You will get a key block that designates the master, and then you will get micro blocks where each block has a transaction or has a bunch of transactions in it, but the block height is the number of key blocks. So you're actually at the same block height. This really confuses Rosetta.
furthermore, you can have a micro fork. So the last few micro blocks at the end of the generation can be kicked out. And this is no problem for us. This is exactly how it's designed. This is by design, by the way. But Rosetta really doesn't like that. What Rosetta expects is that if you have a block, then that block cannot change. So if we all gather all microblocks under the same block, this block suddenly starts changing, and it's really counterintuitive. So Bitcoin NG gives us a lot of flexibility. It gives us a lot of elasticity of how the chain reacts, especially when there's a high load of transactions. But it's radically different from what Bitcoin uses, for example.
Yeah, and yeah, also the fact that the naive coupling to Rosetta would be that when we have a new key block, well, that's the new height and that's the new top. But the transactions coupled with that key block that belong to that transaction, they keep popping in slowly, one microblock at a time. So we can't really present. The question is whether we should present the previous generation as the current top, because that's at least complete. So, I mean, there are semantic differences like that. Well, it takes a little bit of thinking to understand how we should map it so that Rosetta is happy and it's still a reasonable, an intuitive mapping.
But that's not all the problems we had there. Like, no, not even close.
These are the most obvious ones.
Yes, these are only the Bitcoin NG related ones, and we have some. I don't want to go there. It's. I think it's good that we're doing that because we're accumulating some battle experience of our APIs, like what an actual user might need, and etc. And that's all great, and we're improving the system underneath, and we're getting more and more events that we're publishing on blocks, so they could be fed later on Rosetta. But beyond that, it's hard. It's simply hard, and it's time consuming. The next question is how is garbage collection related to hyperchains?
Well, it's not directly related, but one suspicion we have is that once we couple hyperchains with parent chains, syncing will be slower, because basically you now have two chains to verify, and so this makes it even more interesting to have fast sync options so that you don't have to start from scratch. Now, arguably, most hyperchains will be smaller, so maybe that will mitigate the problem a little bit. But we're thinking that having good garbage collection solutions will be definitely interesting for hyperchains.
But also the sizing problem. Like basically the size, it really depends on the problem that the hyperchain is solving. But if you have some short-lived piece of data, for example, it's your hyperchain, you can do whatever you want with it. So you can have some NFTs as names, and they could be expiring, and this could be part of your business model. But you can have millions and millions of names that are expiring, and you don't need to keep them all in the database, especially if they're expired. So this is a mitigation of the size problem. Essentially, if you have a long-running blockchain, it's going to grow, and well, the truth is that the garbage collection thing is long overdue. We should have done that a long time ago, but it really depends on the refactoring that UF is doing at the moment. So it's essentially blocked by it. So one would allow us to do the other. So it's not just hyperchains, but probably the hyperchains are going to benefit the most, as it's going to have a smaller footprint. The hyperchain is going to have a smaller footprint, and yeah. Regarding AeCanary and on-chain security measures taken previously, have there ever been any instances where the attacker has tried to do rollback mining again, where the new 100 block rule has been tested? So the short answer is not really, but sort of yes. So let me elaborate. I cannot really get into details, but there was a connectivity issue in one of the mining pools, and they were mining on their own for quite some time. And later on, they tried reconnecting back to the chain, and because of the 100 blocks threshold, the chain simply rejected their fork. And if that were not the case, what would have happened is that essentially they could have done a 51% attack over the network without them wanting to do so. We're in a collaboration with the miners, or rather, we're helping them because they keep the security of the network. And they informed us that they had network issues. They weren't trying to do a 51% attack. And once those issues were resolved, their nodes started syncing, but the chain refused their forks, and that's when they contacted us saying like, what happened here? Why our nodes are out of sync? So the 100 blocks thingy is battle tested at this point, and it protected the chain. And yeah, back then we didn't have warnings in Canary for that. So we didn't see that in Canary, but we saw it in other tools. I think the next question is for Uf.
Yes. You mentioned Klarna as one use case for RocksDB, LevelDB, but is it an application of Erlang, and what are some other known applications or famous applications of Erlang databases? So yes, Klarna was implemented in Erlang, and some other notable implementations or applications written in Erlang and using, for example, Mnesia would be WhatsApp. I don't know if they're using Mnesia still, because, well, essentially they didn't choose Erlang specifically, but they chose eJabberD, because they wanted to use Jabber, and eJabberD, which is implemented in Erlang, was by far the most scalable and powerful Jabber server out there. And I think they pretty much broke all the records in scalability and the number of Jabber users online. And eJabberD can be configured either to use Mnesia or Postgres. So there are pros and cons of both. I know that for a while they were using the Mnesia option, but I don't know what they've done lately. Yeah, well, that would be the most impressive one, certainly. And there are a lot of other users of eJabberD out there. So I don't know exactly how many people are using Mnesia nowadays, or how many applications are using it. But, well, I know that some people have contacted me and said that they were happy with this slight extension of Mnesia's reach, since it gives significant performance improvements if you are sort of willing to go down a step and be closer to the metal, basically. And so, yeah, some people will probably be pushing to market Mnesia a little bit again and make people rediscover it. But of course, it's there in the middleware. So I think most people are fond of using it. It's just often a question if you want to build a massive cluster, for example, in the cloud, is Mnesia the right choice? And, well, I would say whatever your choice is in that environment, it's going to be a rough ride, just because of the environment and your performance requirements. There are no easy solutions. But that's typically also why you choose Erlang in the first place, because you want to build that kind of application, and then, Erlang will at least give you a manageable amount of pain in the normal case.
Is it difficult or easy for an Elixir developer to create Erlang applications? I don't know who wants to answer that. This is really wide subject, and I guess yes. But people that are from the Ruby context usually prefer the Ruby syntax, and that's why they stick with Elixir. And if you're used to the Erlang syntax,
So I guess maybe I'm the least well suited to answer the question, since I don't really do Elixir programming. But so in the past, people who use Elixir are sort of used to winking in Erlang applications and using them. For example, the Cowboy web server, for example. So using Erlang applications as dependencies in your project, the mix build environment for Elixir has supported that very well. It has been a lot more difficult, actually, for Erlang programmers to use Elixir dependencies in their Erlang projects, because the rebar build tool that Erlang developers typically use has not been able to do that well. I think that has improved slightly in recently, but I haven't tried it myself.
do you know anything about the new vanilla application development? They seem to make use of Erlang and TypeScript as well. Well, this is on the forum, and it's announced, but Greg is not here. Greg is one of the two guys that is developing the vanilla. The vanilla is Well, a service that you can host, open source service that you can host and have a shop to bootstrap your development of a web shop. So it's going to be accepting Eternity payments. So if you want to build a shop using Eternity, you simply clone the repo, add your own design on the web page, and the backend service is there for you, already implemented, and it's not using it's using TypeScript, and it's really vanilla. It's not using the SDK, so the risk of npm injection attacks is 0. You have full control over your source code. So it's progressing, and the guys really love type-safe languages, and that's why the TypeScript and Erlang.
Yeah, and also, I mean, perhaps oddly, since Eternity was developed in Erlang, you might have expected that there would be good application development APIs for Erlang programmers, but Erlang programmers weren't really the audience. So, so we've had REST APIs and JavaScript APIs, but not really Erlang APIs for application developers. So this is also, I guess, in a way, part of vanilla, that, and also the development of the launcher now, that to make it easier to work with the Eternity APIs from within an Erlang node. And that, I think there are quite a few advantages to doing it that way. Certainly a lot less marshalling and communication overhead. So it's going to be interesting to see. Are there more questions?
Not that I'm seeing anywhere.
Well, we're approaching an hour, so
is there anything else regarding, for example, Hyperchains that you wanted to show, or like maybe demo or something, or?
No, that will be the next call.
Okay.
Then Metin is going to show us the new UI, hopefully. And we'll probably have something we've discussed is making releases once a month. And if everything goes by plan, the next go we'll have like 2 more releases and maybe 2 more Hyperchains releases. So we're moving as fast as we can. It's not it's a big and complex task ahead of us still, but we're doing our best to make it to get there as soon as possible.
Okay, sounds great. Really looking forward to see more of the new Hyperchains UI. It will be really fun to play with it.
Yeah.
Okay, I guess then if there's nothing else to discuss, I guess we can close the AMA for today. And yeah, thank you all for joining today, and thank you Ulf, Dimitar, Fabian, and Metin for your time to answer all the questions today.
Yeah, thank you.
Thank you.
Bye.
See you guys.